The word twice differentiable means you can find two derivatives, one after the other, which means all three functions, f, g, and h, are continuous functions. That's what it means, right? Differentiable. Functions with g of 2 equal to 4. They give me 1 point on the function g. The line y equal 4 plus 2/3 x minus 2 is tangent to both graphs of g at 2 and the graph of h at the same 2.
Mr. Aya, that's the AB review. That's
I'm
not
sorry?
the B.
That's AB?
Yeah,
I'm very sorry.
yes.
What an idiot. Okay. I'm start getting confused with all the work that we have. I'm sorry. Here it is. 7. Oh, okay. 7. It says, let a sub n equal 1 over n ln of n for n greater than 3. Let f be the function this. For x greater than or equal to 3, f is continuous, decreasing, and positive. So this here is continuous and decreasing and positive. By the way, this is one of the requirement for the checking. Remember the integral test, where if you make a function of exactly the same and the integral converge, that means the series converge, and if the integral diverge, the series diverge. Anybody remember that? So one of the requirements that the function that you make is continuous, decreasing, and positive. Use the integral test to show this, that this diverges. So I need to show that this integral does not exist, right? Diverges. That's what I need to show. That's the integral test. So I'm doing the integral test by doing what now? Integral of this function dx from what number to what number? From 3. You have to use this number here, 3, right? So from 3 to infinity, which basically I can do it using substitution. If ln of x is u, using u substitution, we can say that let u equal that, then du will equal 1 over x L dx, right? So this will lead to will equal to the integral of this will be your u, right? And 1 over x dx, what's left is the du, right? But of course, this should not be left that way, because you need to change this. When x is 3, what is u? U is ln of 3. So this, instead of 3, you put ln of 3. You have to change the limits. And of course, if x is infinity, u is still infinity, right? Now, what is the integral of 1 over u? It's ln of u. And now we're going to evaluate this. 1 second. Evaluate this between what and what now? Between ln of 3 and we're not going to do infinity. What we're going to do, b, and we're going to write it as limit problem. Anybody remember? We have to write it as a limit as n approach, as x approach infinity.
Isn't it as b approaches infinity?
I'm sorry? No, it's a
Isn't it as b?
I'm sorry, it's a b approach infinity. I apologize. I get caught up with writing, typing stuff. Okay, so I got the b approach infinity of that, which is we're gonna substitute b for u and minus ln of 3, right? That's what we substitute. And now, what's the limit of this as b approach infinity?
Infinity.
Infinity, that means it diverge. And if this diverge, that sigma diverge also. I proved what they want me to prove. Done? Done. Next, part B. Consider the infinite series this. Now, this is not the same. What's the difference between this and the one that we just proved to diverge? It's alternating. It doesn't mean that it will diverge also, because alternating is different than the positive one, correct? Okay, identify the property of the series that guarantee the series converges. Okay, explain why the sum of the series is less than 1/3. So let's do one thing at a time. First, why it diverges? Because the limit of the n term, limit of a sub n. Okay, let me do this. I'm copying this and paste on it. The limit as n approach infinity of the term number n is how much? When you put infinity for n, what would that be?
0.
0. And that's the first requirement, isn't it? 0. Now, if you follow the terms of this sequence, it's 1/3 ln of 3, 1/4 ln of 4, 1/5 ln of 5. That means it is decreasing. It's obvious to me that the denominator is getting bigger, which means the value of the fraction is getting smaller. So, one sentence after this stating, since the series, right, is decreasing and the limit as n approach infinity of a sub n equal to 0, right, then the alternating series converges, right? Now the more difficult question is to explain why the sum of the series is less than 1/3. What do you notice here? That I cannot find the sum of this. No one can. Anybody can? This is not geometric, so I cannot find this sum of this series. What can I do? I can find a partial sum. What's the partial sum? Can you add a 1 or 2 or 3 or whatever you can, whatever you want? To make it simple for myself, I'm adding only one term. I'm going to do this. Look. Am I allowed to add one term only? Yes. I'm adding one term. So the sum of one term of one term equal to this. This is the sum of one term. Is it?
Yeah.
Yes. Is this less than 1/3?
Yeah.
Is that a yes or no?
Yes.
Yes, it is less than 1/3 because the denominator is bigger than 3. This is a value, by the way, bigger than a 1. This is a value. No, it's not a value. It is a value bigger than 1 because this is bigger than E. 3 is bigger than E. That means this is a value bigger than 1, which makes this bigger than 1 times 3 is bigger than 3. That means 1 over bigger than 3 is less than 1/3. So this is less than 1/3 as it is, right? And if you add only one term, what would the error be?
The next term.
According to the alternating series, it's the next term, right? So the next term is the alternating. That's your error. That means, what is the maximum you can get for this function? The maximum is this plus that, right? Plus the error. Make sense? If you add those two together, is that less or more than 1/3? Can anybody do it with the calculator, please, and tell us what's the answer?
I got 0.48.
0.48, that means it's bigger.
Yeah.
Then you have to do this using
2
more than one term. I made it one term only. I added one term only, and I got that, right?
Yeah.
How about if I make it two terms? Sum of two. The sum of two would be this minus that, isn't it? That's a sum of two. Okay, can anybody tell me what the answer for that then?
I got 0.123.
1, 2, 3, right?
Yeah.
And then what would be the error in this case? The error will not be that. The error will be a 5. The next term is the 5. Yes? And if I take this value and add the 5 to it, what would the answer be now?
0.247.
That's less than 1/3.
Yes.
Then the maximum value is still less than 1/3. Then we're okay now. You see what I did? That's all I can do, by the way. There's nothing else I can do but finding the error this way and add it.
How do we say that limit b approaches infinity is 0 right away in the first part?
Which one? For
B.
this?
No, for b.
What do you mean the limit? That limit is 0?
Yeah.
Because when you put an infinity here, 1 over infinity is 0.
But in A we use the integral
No,
test.
they ask you to use the integral. So I'm using the integral.
Okay.
But they ask me to use the integral, and because the integral diverge, they want to say that this positive one diverges, which is the rule about the integral. They want you to use the integral test. So I'm using it. What am I going to say? No, I'm not using the test that you asked me. I'm going to do my own thing. No. Okay. Here, I want to show the alternating series converges. And by the way, they might give you an alternating series asking you if it converges or diverge, because this is what they cut the section, the chapter very deep. So the only thing that they can ask you about is integral test, alternating test, right? Conversion, diverge. They can ask you about geometric series to add. So if they ever ask you to add a series, think of geometric, test it if it's geometric or not, because if it is, that's what you do. You add it with geometric formula, the a over 1 minus r, right? They might ask you about that. That's the sections that they say it's on the test. And basic idea of Taylor-Maclaurin, not a deep one. Like, for example, this interval of convergence is not on the test. I put it there because it's there. It's in the book, but it's not on the test. They said this is not on the test.
Also for B, would it be conditionally convergent?
This would be conditionally convergence, yes.
And how do you know the divergent part? We said
how do I know the divergence part? Because I proved it in part A.
All right.
Yeah, I love your questions when you say, how do you know what you just proved? Right?
Yeah.
Okay. So we're done with that. Anything else? Or should I? I'm sorry? Number 3, sure, sir. Number 3. It says the continuous function f is defined on the closed interval from -6 to 5. So what's drawn here is -2 to 5, but the function is continuous from -6. So there's a part here that I don't see, right? The figure above shows a portion of that function. F consists of 2 line segments, 1, 2, and a quarter of a circle. This is the quarter of a circle right here, with a center 5, 3. So the center of this circle is right there, 5, 3. It is known that 0.3, 3 minus radical 5 is on the function f. So this is another information here about my function f. Part A. If integral from -6 to 5, from -6, which is beginning, I don't know part of it, all the way to 5 equal to 7. Find the value of the integral from -6 to 2. This is based on the knowledge of the definition of that integral thing. We learned that the integral from a to b plus the integral from b to c, same as the integral from a to c. Anybody remember that? So I'm saying the integral from -6 all the way to 5, same as the integral from -6 to -2. Oops, what am I doing? I'm sorry. -2, and then plus the integral from -2 to 5. Is that clear? Because the integral means area. Oh, it's written wrong completely. Equal, that's it. So we integral of part of that plus the other part will be integral of the whole thing. Area plus area equal the whole bigger area. Basically, let me draw here. If this is -6 here, the area from -6 to -2 plus the area that we got here from -2 all the way to 5 will give me the area from -6 all the way to 5. That's what this is, right? Okay. All you have to do now is substitute the numbers that you know. I'm copying this, and each one I know I'm putting a number for. So this one, it's given to me as 7. So I'm putting 7. This one is what's hidden here from -6 to 2. I don't know, I don't see it, and that's what the question is asking me to get. The integral from -2 to 5, from -2 to 5 is this area. So let's get that area. First area is the triangle that's in here. Let's again try to draw something. This is the first area, the triangle, which is half. Base is 1, height is 1, right? So, I'm sorry. I'm erasing that. I'm putting half times 1 times 1. And then minus. Why minus? Because the next triangle is below the x. It's half again. Times the base is 2. Times the height of it is 1. So I got the area of this triangle and I made it negative because it's below the x. Next is, oh, wait a minute. I made a mistake already. It's from 1 to half. That's not 2, that's 1.5. That's a 3/2, the base. The base is 3 over 2. I'm sorry that I'm blind. Next triangle is this one here. And the base is 1.5. The height is 3. So what is it now? It's a plus half times 3 over, the base is 3 over 2, and the height is 3. Last thing is this area here. This area here between for the quarter of a circle. Remember something here. The center was here. This is a quarter of a circle. The area of a quarter of a circle with a radius of 3 is 9 pi r squared. Yes, pi over 4, because I'm dividing the whole area of a circle by 4. But this is not the answer that we're looking for, because this is not the integral. This is the area of this quarter of a circle. But what they ask for, or what the integral say, is the area between the graph and the x-axis. Which is that? How you find this area from geometry? You would say this is a square, 3 by 3, 9, area 9, minus the quarter of a circle. So that's what I'm going to do here. So this would be plus 9 minus 9 pi. Where's that? Pi over 4. And that's it. I just combine whatever look alike and get my answer. Is that okay? Okay, next part. Evaluate this integral. Again, the whole question here is based on the knowledge of what the integral means. So how can I find an integral for stuff here that I don't know? I can separate this. If there's a plus there, I can separate it into multiple integrals. So equal, apologize. This plus that. First integral, I'm going to leave the 2f prime of x. And the second one, I'm just going to leave the 4. So I divided this into 2f prime of x and a 4. 2f prime of x and a 4. For this one, to get the answer is easy, because what's the integral of 4? 4x. Evaluate with 5 minus evaluate with 3. That's how we do it. What about the first one? How can I do this? First, the 2 is constant, and the constant should go outside. And then what's the integral of a derivative? Integral of a derivative, according to the meaning of integral, is to go back to the original function. That means this equal to f of x. And then evaluate the function with 5 minus evaluate the function with 3. So what would that equal to now? This is f of x what am I doing? I'm sorry. F of x, and then evaluate that with, I need to shut this up. 1 second, guys, I'm sorry. Evaluated with 3 to 5. And then the other one is 4x, and evaluate the same way 3 to 5. Nope. Okay, whatever. No, I'm not going to do it. Okay, here it is. 3 to 5. Okay, equal to. The first one, the value of the function at 5 minus the value of the function at 3. Okay, what's the value of the function at 5? 0. What's the value of the function at 3? Anybody know? What's the value of the function here at 3?
3 minus
3
5.
minus root 5.
It's given right there. You should not be estimating it. It's given right there. I'm just testing you. So it is 3 minus root 5, right? So what we have here, we have, where is it? It's right here. We have this to be parentheses, which is 0 minus that. Oh, hold on a second now. When you're minusing that, you need to distribute. So this is going to be a plus, minus 3 plus radical 5 because we minusing both. Make sense? I'm distributing the minus over it. And here, when you put a 5, you get 20. And when you put a 3 for x, you get what? 12? So 20 minus 12 is 8. The answer is 8. So what's the answer at the end? The answer at the end is negative 6 plus 8. That is 2 plus 2 root 5. 2 root 5. Does it make sense? You just have to break it down and find the answer for each part of it. Now part C. The function g is given by that g of x equal to the integral of that. Find the absolute maximum value of this function over the interval negative 2 to 5. Negative 2 to 5 is where the graph is given here. Okay. We learn every time you see a function is integral of another from number to x, what does it mean? Means if you get the derivative of both sides, g prime of x will equal f of x. What that means again, the function g that we don't know anything about has a derivative, and the derivative same as what we see in the graph. So that graph is the derivative of a function g. If you wish to find max or min of any function, what do you need? First, critical numbers. Critical numbers means when the derivative equals 0. When this derivative equals 0, it equals you at negative 1, and it equals you at 0.5. So I find out that the function cross the x-axis at negative 1.5. And those are the critical numbers. Next, I evaluate my function at the beginning, negative 2. By the way, here's your function. When you put negative 2 for x, that's when you evaluate it. Integral from negative 2 to negative 2 is 0. Now, integral at negative 1 being the critical number, and that's when we find the area. We did find that area before, and it would equal to half. So that's why I put equal to half. Last one is g of 5 is when you put a 5 here for x, which basically represent the area from beginning to the end, which again we found in here, right? Integral from negative 2 to 5, that was the question. Was it? No, that was whatever area that we put in here, right? And that's what it equals to. That area that we found here is the number that we put in there. Now, which one is the greatest number of all these? Is that one. Now the secret question is this. Why I did not evaluate with the half? Because I found out that the half represent relative minimum, not maximum. And I'm not going to use relative minimum to evaluate a function to find the maximum of a function, right? It makes no sense, and that's why I ignored it. If you don't want to ignore it, go ahead and get it, no problem, and it's not going to be the maximum anyway. Last part of this question was find the limit of something here. When I found the limit of this, I found out if I put the numbers in, I'm not getting a 0 over 0 or infinity over infinity. I'm getting a value. So that's my value. That's my limit. It's just replace this with numbers. And that's it. Anybody have a question about it? I'll repeat it. If you have any question about this, I'll say it again. Okay. Okay, let's go back to our new or last one of two, actually. This is one of two last, what do you call it? Review for the final exam. As you can see here, I have a final review number 1 and a final review number 2. I made them a little bit longer this time, so bear with me, and I'm sorry, but this is the last week we can do any work. And let's review for the AP. Can you please read and we do this together? The Maclaurin series for e to the x. That's the one that we said memorize, and you can look it up anyway if you have to, because it's open book test. So no problem here. This is the e to the x. They said there's a function called the f of x which equal to e to the x minus 1 all squared minus 1 over x minus 1 all squared. For x does not equal to 1, find, and f of 1 equal to 1, so this is another given here, f of 1 equal to 1. The function f has a derivative for all orders at 1. Part A. Write the first 4 non-zero terms and the general term of Taylor series for e to x minus 1 all squared for about, there's no 4, about x equal 1. How would you get this? Should I go and get derivatives for e to the x minus 1 all squared and put them in the formula that we're supposed to memorize? Never. That will be way, way too hard. And no one should be doing that. The only thing I can do is copy the e. This is the series that they give us for the e. They give it to us for a reason. Copy that and substitute. Instead of x, oh, this is, I'm going to break that phone. Instead of e to the x, you substitute every x with whatever you want here. Can you please do this substitution, including the general term and the first 4 terms? They want the first 4 terms and the general term about x equal 1. This is going to happen by just simple substitution. Let's do it. I'm giving you like a minute to write down the answer. Okay? And then I'll go over it. Okay, so this is, again, it's extremely simple. Look what I'm doing here. All I have to do is to go to whatever they want me to do, and I'm copying that, right? Go here for e to the x, and every x, I'm pasting the same. See, in the original function, when you replace the x with this parentheses squared, you get exactly the function that they're asking for, right? It happened that you substitute the same. So instead of x here, I'm putting the parentheses squared. And instead of x here, I'm putting parentheses squared. But be careful, because squared being squared, that means the exponent become 4, right? Same here. You put x squared, but now the exponent become 6, because you're supposed to multiply the exponents. How about the general term now? If you put the parentheses squared, you get raised to 2n. You multiply the exponent, 2 times n, and done. If you think about it, substitution is not that hard, not that heavy. Part B, use Taylor series found in part A, that one that we found in part A. Write the first 4 non-zero terms and the general term of Taylor series for f about x equal 1. Here's your f. Okay, we need to build f using this. What would I do to get this? Step 1, I'm going to do it in steps. I am not going to do this right away. I'm going to do it in steps. Step 1, I want to find the top. Only the top. When you find that top, what do you need to do to e raised to x minus 1 all squared?
Just subtract 1.
Subtract 1. So here, we're going to say minus 1 from this side. Yes? And we go to the other side, and what do we do? Minus 1 also. Because whatever you do to one side of the equation, you need to do to the other side. Okay. Last year, I was really hitting my head against the wall. You know why? Some of the students did the following. They want to subtract 1 from this function, right? Polynomial function. What did they do? They went and subtracted 1 from each term.
No.
Is that what we do with algebra?
No.
Do we need to, when you subtract expression from another, you subtract from each term? No. You only combine the ones that look alike. Which ones here look alike? The one in the beginning, done, with the one at the end. 1 minus 1 is 0, gone. And that's your answer, right? Now, what do you need to do to this to create f? You need to divide this quantity by the parentheses squared. So if I divide this by the parentheses squared, I'm going to divide all that by the parentheses squared, right? But hold on. If I divide this by the parentheses squared, should I divide each one? Now, yes. That's how we divide. When you divide by one quantity, you take each term and divide by that quantity. You don't just divide one of them, right? So if I divide the first term here by the parentheses squared, what would it be?
1.
1. If I divide that by the parentheses squared, what would it be? Subtract exponents, right? X minus 1 to the 4th divided by x minus 1 squared. Subtract exponent, you get 2. How about the next one? What would the exponent be? 4. We subtract exponent when we divide. How about the last one here, the general term? It would be subtract exponent minus 2. And that's your, that's not that.
We need
That's
4 terms, right?
1, 2, 3. They ask for 4?
Yeah.
Okay, give me a second there. Okay. Okay, let's add one more. What do you expect? Follow the pattern. If I follow the pattern, what would the next one be?
So it'd be to the 6th.
It would be to the 6th. Thank you. And divided by,
4 factorial, so 24.
I'm sorry, it's not factorial now. Hold on a second. I'm starting by dividing by 2, 4, 6. What's the next number that should be? That's,
4.
hold on.
You wrote the general term.
Wait a minute, there's a mistake here. 1 second. E to the x is not that. This is not 6. This is never 6. This is 3.
No. Ah.
In the original one, I made a mistake in copying.
Oh.
The original one here, it's the same number. 1 over 1. X over 1 over 2. No, wait. Oh, it's factorial. It's factorial. So this is 3 factorial? No,
Yeah.
it's not.
It is.
Yeah, it is. Can anybody look it up? It's a 3 factorial, isn't it? That means this was correct.
It is.
It is?
Yeah.
Okay, thank you. So this is 2 factorial and this is 3 factorial. Then this would be 4 factorial, right? Which is 24. Right? 4
Yeah.
factorial, which is 24. So that's what it is. Okay. Now what? Use the ratio test. Forget the ratio test. It's not on our test, so I'm going to cancel it. Is that okay?
Ratio test and what's the other one? Ratio test not on it, right?
I'm sorry?
Ratio test.
You want me to do it? I'll do it.
Wait, no, but if it's on the test, I don't care.
Yeah, if it's not on the test, so let's just ignore it.
All right.
Okay. There is the ratio test on regular sigmas. Don't get me wrong now. There is a sigma without an x, right?
Yeah.
The one that we did before Taylor-Maclaurin, when we did the ratio test, that's there.
With the limits.
But they're not going to ask you to use the ratio test on power series, on this kind of series.
Oh.
We're not doing interval convergence, right?
You're not doing the interval of convergence. No.
All right, good.
It's not. I read it, and it's not. They said this is not what's on the test. What's on the test is the series that we learned, the alternating, the ratio test could be there, the integral test could be there, right? The alternating test to find out if alternating series converge or diverge is there, and then Taylor-Maclaurin. So the Taylor-Maclaurin would be basic. Taylor-Maclaurin does not contain this.
This?
Yeah?
Yeah.
Okay. If you want me to do it, I'll do it. It's just that to me, I think it's a waste of time now. Next problem says use Taylor series for f about 1. By the way, you don't make it about 1. We did not make this centered about 1. It's just when we substitute it, it become on its own around 1. Right? Do you understand that?
Mm-hmm.
About x equal 1 to determine whether the graph of f has a point of inflection. I would like to know if the graph of f has a point of inflection. How would I know? Get a second derivative, see if it's 0. Right? Find the second derivative and see if it equal to 0.
Mr.
Yes.
Aya,
What's up?
for part A, since it's centered about x equals 1, do you have to substitute that?
Substitute what?
All the x's with 1.
The point of inflection has to be around center or nothing at all.
No, I'm talking about for part A.
What about part A?
It says it's about x equals 1.
It is about x equal 1 right here.
Oh, okay, got it.
That's what I said. I said you don't intentionally make it around 1. It become around 1 when you substitute.
Okay, yeah, sorry, I didn't.
So the change from around 0 from the e to the x was around 0. And then when you substitute it become around 1. They
Yeah.
said that around 1 because what you get after substitution is around 1.
Got
So you're
it.
not going to make that yourself. It's going to be done automatically when you substitute.
Okay.
Okay, great. So now what? Now we're going to get the second derivative of this, correct? Right? We're going to test it if there's inflection or not. So let's get a second derivative. Here's my first derivative, f prime of x. When I get my first derivative constant is 0. When I get a derivative of this, I'm considering each parenthesis as if it's variable, right? And that's how I'm going to get my derivative. I am not going to FOIL anything or do anything weird. I'm taking each parenthesis as if it's one variable. So I have a variable squared. That would be 2 times
X minus
the variable, correct?
Yep.
That's my derivative. How about this derivative? 4 times,
x minus 1.
oops, I'm sorry, 3, right?
Yeah.
And then 6 times 5. And over here, you're going to have to put parentheses. And you say it's n. I'm sorry, 2n. 2n minus 2 minus 1, right? That means minus 3? No. Minus 1 is here. That makes this minus 3, right?
Can we leave out the general formula?
I'm sorry?
Can we
Yeah, I'm
leave
leaving
out
the whole thing
general
all the way to
formula?
infinity because it's supposed to be. I'm supposed to evaluate it all the way to infinity.
Isn't only like the first terms important?
What do you mean?
Okay.
What do you mean the first term is important?
I think he's asking whether or not we need to do the general term.
If you don't include
just
the
did.
last part. No, would I lose points if I didn't include that?
If they ask for it and you don't include it, you're gonna lose. Of course, they're gonna put 1 point to all the 4. Like here, when they ask for 4 terms and a general, those 4 is 1 point. This general is 1 point. You don't write one of the 2, you lose 1 point. That's how it is.
But
Here,
indeed,
I'm using it anyway.
Just in case.
Because that was part of my thing here, and I want to make sure to show them that I'm doing it all the way to infinity. That's all. That's why I'm doing that.
Okay.
But it's a derivative, for God's sake. It's
Okay.
exponent times the parentheses raised to 1 less. I mean, that's really difficult? No.
No.
Now I'm getting a second derivative. If you get a second derivative here, what would that be?
That would just,
That would be a 1. No?
yes.
And then what would that be? That would be 12, and the exponent is 2. And then this would be 30, and the exponent is 4. That would be times another parentheses, right?
Yeah.
Which is inside that parentheses will be 2x minus 3, and the exponent is minus 4. Is that right so far? Yeah?
Yep.
Okay. Now I want inflection. So I want to make sure that f of 1 is 0. If you put f of 1, would you get a 0?
Yep.
Huh?
Yes.
No.
No. You would get every term here becomes 0, but plus 1 at the end. So
Ah,
f of double prime of 0 of 1, I'm sorry, is 1. It's not a 0. That means no point of inflection.
Okay.
Yes?
Yep.
What if this was 0? Yes? This does not exist. What if this doesn't exist? Can I say there's a point of inflection now?
Yeah.
Is when the second
Oh.
derivative is 0, that's good enough for you, sir? Or you need to check concavity before and after?
Yeah, you have to check concavity.
You have to check concavity. Let's try to check concavity. First of all, I have to add all of it, all the way to infinity before and after. If I cannot, then I don't know if it's positive or negative, do I?
Mm.
But can I tell if this is positive or negative before and after?
No.
Yes, I can.
Oh.
Put any number bigger than 2. Bigger than 2. Bigger than 1, I'm sorry. Bigger than 1. Do you see that all the exponents are even? Which leads to positive answer.
Oh, yeah.
Even if the
Okay.
inside is positive or the inside is negative, the answer at the end would be positive. And the all pluses, no alternating. That means before the 0 it was positive, after the 0 is still positive. There's no change in sign, which means, again, still not point of inflection. Yes?
Yeah.
Okay. This, I'm going to leave those 2 for you to have fun with for homework. And if you have a question, again, I will answer.
Wait, Mr.
Okay, because this is too many. How about we do one more fast? Please?
Okay.
I know the time is up, but can we just do one more fast? So at least I make the load less for you because it's too many questions. I'm trying to do as much review as I can. So now let's do 4. Consider differential equation. Yes? Let f of y equal f of x be particular solution to the differential equation with initial condition f of -1 is 2. Use Euler with 2 steps, starting at x equal -1 to approximate f of 0. Show the work that lead to your answer. Anybody remember the formula that we use for Euler? It's f of b equal, please write it somewhere, have it in front of you. If you have to use it, use it. So you don't have to even memorize. F prime of a times delta x. I don't know where the delta is. I forgot. Here's delta x plus f of a. And then we use it twice. One time we're going to get f of negative. We said 2 steps, right? So the first step is to find f of negative what?
1/2.
Yeah, middle of the way between -1 and 0. The second time, we're going to use it to find f of 0, and that's what they want to see. Would you be able to fill in the numbers? I'll give you a minute. Five minutes, man. Okay. How you find the derivative?
You use
The first point we use is the given point, right? X equal -1. So basically, to find the derivative at -1, you substitute x with -1 and a y with 2. And if you do so, what would you get? You get 4. And the delta x is
0.5.
0.5, isn't it?
Yeah.
And then f of a was the 2. F of -1 was equal to 2. So the answer for this one now is 4. So the new point that we have is -0.5 and 4. This is the numbers that we're going to use in the next one. So f of prime at that point means put the numbers in here. -0.5 squared is a quarter. Let's make it a quarter. And this is a quarter times 4 is a 1. A quarter times that is 3/2. So 3/2 minus 1 is half. So the derivative here is half. If I'm wrong, need to hear from any of you, please. And the delta x is, again, 0.5. And f of a is the 4. Now, what is that equal to? Equal to 4.25. And that's what I got. Any question? Okay. Part B. At the point -1, 2, the value of the second derivative is -12. Find the second degree Taylor polynomial at x equal -1. That should be easy. The polynomial that they're asking for equal to f of -1. F of -1 happened to be the 2. So that's the first thing I'm putting here. 2 plus derivative times x minus -1. What's the derivative? The derivative at -1, we found it before, and was 4, wasn't it? It was here 4. So the derivative times x, 4 times x plus 1. Why is it plus 1? Because minus the -1. Then the last one is the second derivative. That's why they give me the -12 divided by 2 factorial, right? Times the x minus 1, the x minus -1, the x minus -1 all squared, right? And that's what I do. Done. Of course, this I can write it as 6, right? So I'm going to write this as 6. And we're done with that. Now they want you to solve the differential equation. So I'm taking that and try to solve the differential equation. Can anybody tell me what steps should I use?
Multiply both sides by dx.
Multiply both sides by dx. I have another idea. Can I factor this side and take x squared as a common factor? Because that would help separating the x and the y.
I mean, yeah, you can do that after you multiply by dx.
You want to do it after?
Yeah.
Okay, sir. You don't want to follow what I say? Don't follow what I say. I'm doing what you tell me now.
All right.
dx. You're the man. Okay? So now we take the x squared as a common factor?
Yep.
Okay, thank you for allowing me. Here you go. Now we can divide by the parentheses.
Yeah.
So if I divide by the parentheses, it would disappear from here. And it will appear there. After doing so, I get the integral of both sides. So the integral of that equal the integral of this. Oops, no, integral of this. Next is to find the answer for the integral. The answer for this side is ln of the absolute value. Don't forget the absolute value of 6 minus y. And on that side, I have x to the third over 3. Or if you wish to write it as a 1/3 x, that's fine by me, plus c. What's my next step? Is to find, find the c. How you find the c? By using the initial condition that's right there. So I am copying the y as a 2 and the x as a -1.
Wait, Mr. Hayat, shouldn't it be a negative ln?
I'm sorry?
Shouldn't it be a negative ln?
It should be a negative ln. So why did you say ln without the negative? It's your fault. Oh, man. I should not be here today, by the way. I was going to send you an email to apologize and not do anything today. I was like about to throw up all night long. I ate heavy stuff and I went straight to bed, and I forgot that I'm getting old and I cannot do that anymore. So I was suffering for the whole night, seriously. Anyway, thank you, sir, for telling me. I really appreciate it. So what's the answer now? The answer is something weird, which is, it's ln of 4, right?
Yeah.
And this would be positive, -1/3 here. So I'm going to cross it out and put it as a positive, plus 1/3 there. And that's it. That's a C. So my equation is, and instead of the C, I'm going to put a plus ln of 4 plus 1/3. Is that right? Right. Okay, what's next? What's next is multiply everything by negative so I can get rid of that negative. So here's negative. And what is going on here? Isn't that supposed to be, oh, I'm copying the equation. I copied this instead of the equation. That's x, right? Right?
Wait, isn't it negative ln of 4 since we established?
Wait. Is it, hold on. Yes, it is. Yes, it is. That was negative ln of 4. Negative, oh my God. Negative ln of 4 and a plus 1/3. That was the C, right?
Yeah.
Now I'm multiplying by -1. So multiply by -1, that would be a negative. That go back to positive, right? And that go back to negative, correct? Is this step correct so far?
Yeah.
Okay, now we're going to solve this equation by saying by saying 6 minus y. Oh, I forgot. This is supposed to be a y. Okay, 1 second, please. Equation. 6 minus y equal to e, right? E raised to all that. And this is not there. Is that right?
Yeah.
Yeah.
What happened? Okay, so now when you solve this absolute value equation, you need a plus or minus, correct? So I'm going to copy that, write it again, and
Mr. Ayad,
this will be only what 6 minus y.
Mr. Ayad,
Yes, sir.
since there's the ln of 4, should we just take that down and make it 4 times?
Yeah, I'm
e?
going to do that. I'm going to do that, I swear.
Okay.
And here I'm going to put plus or minus. Plus or minus. Yes?
Yep.
Now, which one should we use? If I put in -1 here for x, what would this be? If you put a -1 for x, this would be a 1/3, positive 1/3, minus 1/3 is gone. So it's e raised to ln of 4, which is 4. Is that a 4? When you put 2 for y? Yes. So you need the positive? Yes, I do need the positive. What happened there? Need the positive, right? And
Yeah.
this can be written as, now whatever he said, equal to 1 and 2. So this without the ln of 4, and this only ln of 4. I'm separating them as 2. No, it's not negative, is it? It's not negative ln of 4. Okay, that's what it is. And e to the ln of 4 is actually 4, so you can put that 4 in the front as multiplication. Whenever you have e raised to ln, we can write it as a whole number for multiplied, not added. That would be it. Yes? Okay. So now we finished 4, but we ignored number 2 and 3.
Mr. Ayad,
Yes, sir.
don't you have to isolate the y now?
Oh my God, man. Why you hate me, man? Okay. He's absolutely right. It is a y equal, and that would be 6 minus that, right?
Yeah.
Okay. So that's the end answer.
If you
Thank you.
if you don't simplify the absolute value inside, like for the x, would that wait?
You
Actually, no.
lose
The
points.
the ln
you
of
do-
absolute value of 4. Thing. The ln of 4. If you just keep it that, would that be points?
What do you want to do? You want to keep it ln of 4? You want to keep it as what?
No, like lower down. When you took out e to the ln of 4 out of the exponent.
Uh-huh.
What if you don't do that? Would that be points?
If you don't do that, I don't think they're going to do anything to you. It just look very ugly.
Oh, okay.
It give me a sense that you're weak in math. That's
Oh.
all it is. Okay, like
Alright.
somebody writing x times x. Would that be wrong scientifically? No, it's not. But normally we write it x squared if we know math, right? It's just like that. Okay, can we finish up to 5, please? That would be 3 problems. And if you see limit the interval of conversions, you can not ignore it. Don't do it. How's that?
Okay.
So tomorrow we'll go over like the ones we're doing today for Homer.
Yes, of course. If you have any
Okay.
question, please. I'm willing to stay longer, by the way. I'm not strict here and trying to kick you out as soon as I get 12 o'clock. Okay? If we allowed to stay, I'm staying as long as you need to go over stuff.
All right.
I'm just trying to get as variety of problems at the same time. Okay, good luck, and I'll see you tomorrow, guys.